Hi, my name is Mark Parish. I represent Turpin Sales and Marketing. We put together a series of presentations called Machining Basics that may attract people into the industry who've never considered it before. This is the second of a series of presentations and we'll concentrate on turning operations. So why are Turpin Sales and Marketing putting these presentations together? Well, the machining industry is facing a massive problem right now in lots of ways, but specifically in the shortage of skilled machinists. So we put together a series of presentations which are very basic and they were developed with the intent to stimulate some interest from people who may want to come into this industry who've never considered it before. So who are Turpin Sales and Marketing? We're the leading manufacturer sales representative team in the metalworking industry in the Northeast. We represent superior products and have extensive knowledge in the metalworking industry that our customers have relied on for over 30 years. We have focused on cutting tools, work holding, tool holding, fluids for many industries, aerospace, firearms, medical and automotive. Through our technical expertise and selling skills, we provide the end user and distributor with increased productivity and profitability. This is achieved by assisting our distributors, end users, in presenting and implementing the quality products that we represent to the end user in a knowledgeable and professional manner. The metalworking industry is facing many challenges right now. Supply chain, material availability, but I believe the biggest one we're facing is the skills gap. So what is the skills gap and what can we do about it? The skills gap is basically a shortage of skilled labor in the manufacturing and machining industry. No one's going to trade school. No one's doing apprenticeships. Skilled labor is very difficult to find. It's predicted that 3.5 million manufacturing jobs will be unfulfilled in the next decade, which will be devastating for this industry. So what can we all do to improve this situation? Do you have existing employees that have an interest in manufacturing? Maybe you hire a person with mechanical aptitude, good work ethic, but no manufacturing skills. So what's the solution? Train your own. So Turpin Sales and Marketing have put together a very basic series of training presentations to help to inspire people who may want to know more about this industry and help to bridge the skills gap. In our last short presentation, we discussed the type of machinery that can be found on the shop floor. Today, we're going to concentrate on the lathe or the turning lathe, as you can see in the picture here. This can perform a variety of operations and produce a variety of components, from a simple shaft to a much more complex multi-diameter radial hole threaded components, as you can see on the right. Following slides will discuss each of these operations. In our last presentation, we discussed the different types of machines that can be seen on the shop floor. In this presentation, we will concentrate on the lathe. Lots of different operations can be done on the lathe, and you can see them on this slide, from facing, taper turning, contour turning, to knurling, drilling, boring, etc. We'll take a quick look at each one of those. This is the most common operation done on a lathe. It's called OD turning, or outside diameter turning. You can see the material there is held in a chuck. The material is predominantly round, and you can see the cutting tool held in a tool holder on a turret, which is stationary but does move axially or radial to remove material from the part. The next one we'll take a quick look at is called profiling. Very similar to the last one, where the round component is held in a chuck and the tool is held in a tool holder. The chuck rotates and the tool holder is stationary. But in this case, it follows the shape of the workpiece that you're trying to produce. You can see on this slide there are multiple diameters, multiple faces. So this is called profiling because it creates the profile onto a component. We've already looked at OD turning. This is ID turning or boring, inside diameter turning or boring. Very similar, that the material rotates and the tool is stationary but moves axially and radially. Normally you would need a pre-drilled hole for the boring bar to go in. Most of the time you would drill first and then you would open up to the required diameter with a boring bar. Another very common operation performed on a lathe is called facing and cutoff. All the same principles apply, that the component rotates and the tool is stationary, but in order to cut off, the tool will need to travel radially across the component to create a large groove and eventually goes to center, which cuts off that piece of material to the required length. As we saw on previous slides, internal and external turn-in, or boring for the internal and turning for the external, we can produce threads, both internal and external. The main difference here is that the insert is produced with the pitch of the thread on the insert, and the feed rate is programmed to the pitch of the thread. So as that insert moves along, it produces the thread. Normally it would require multiple passes to produce the thread. The final one we'll take a look at today is grooving. Again, all the same principles apply. The component rotates, the tool is stationary but moves along axially or radially. You can see on this that there are multiple types of groove. It could be an O-ring groove, it could be a clearance groove, it could be wide, it could be thin. Lots of different reasons for putting a groove into a component, but exactly the same principle. You may have noticed a theme throughout these slides, but it's all very, very similar on a lathe. That concludes the second in a series of basic machining videos. Thank you for watching. There will be more posted in the near future, but please visit www.turpinsales.com or go to our YouTube channel, Turpin Sales. Thank you for listening.